Hello everybody, welcome here to another video by JFB, and in this video I'm finally going to introduce a new topic, and that topic is computer architecture. So we're moving on from our previous topic, which was called logic gates. If you didn't watch the entire series, or maybe if you watched some, I highly recommend for you to finish that topic because it's one of the most fundamental topics to computer science and maybe any other electronics topic that you take. So just go into the YouTube channel itself, search for logic gates or basics of computer science, you find it, and please watch that series. And also watch the series about binary numbers because we're gonna use them a lot in this new topic of computer architecture. If you have a solid foundation in all the topics which I've said, then you are well and good. Let's start. So, computer architecture is simply how the computer systems are organized, and I'll say organized and structured. That's all it is to computer architecture. So, like a house, how a house is built and all those things, its architecture is maybe the roofings, the building itself, the blocks, and all those things. How all those things are structured in order for you to have a beautiful house. So that's like how computer architecture is. It's how a computer itself is structured in order for you to have a computer which is working, maybe the computer even using to watch this video or your smartphone, how all those things are structured. So when I say a computer, I'm not talking about your keyboard or maybe your mouse, your microphone, your camera, and all those things. When I say computer, I'm actually talking about the CPU, the CPU. And what does CPU stand for? CPU stands for Central Processing Unit. So by its definition itself, and the word processing in it, it simply states that that's where all your instructions and everything is processed or executed, and all your computations are done. That's what central processing unit actually means. So it's a very small chip that's found on your motherboard in the computer, and that's where all your instructions, your additions, your pluses, the graphics, and some of the things, but sometimes graphics are computed on a GPU. But I won't get into what the GPU is. Just know that the GPU computes graphics, and the GPU stands for graphic processing unit. So graphics processing unit, and that's where your graphics are processed. So the graphics in which you are seeing this video right now and how I'm rolling around the pen is computed by the GPU. In some systems, you don't even have a GPU. Your GPU is actually found within the CPU itself. But we're just gonna focus on the CPU. Don't worry about the GPU and how your graphics are being processed and all that. Just focus on the CPU, which is actually carrying out computations like 2 plus 2 in your computer. So the CPU is a small chip that's found in your motherboard. So it might be called something like maybe Intel Core i7. That Core i7 sticker you always see on your computer, or the Core i5 you see, or maybe the AMD something that you have on your computer, or maybe the ARM processor and all those things. They're just telling you what type of CPU is inside your computer. And like all computers in this world, they follow one architecture. Okay, most of them have different architectures, but they don't drift off from the main architecture. And that architecture which your computer is using is called the Von Neumann architecture. That's the same architecture your computer is using to execute all the instructions you're giving it right now. The von Neumann architecture, which your computer is using to execute all those instructions, was made by John Von Neumann. So John Von, I'll just say N here. John Von Neumann made the von Neumann architecture. Okay, he made the architecture, then the architecture was just named after his name. So the von Neumann architecture. It was about in the year 1945. So why did von Neumann go to the ends of making an entirely new architecture on which the computer was built? Well, old computers and historic computers never had stored programs. And what do I mean by stored programs? Well, stored programs are simply the programs which your computer is actually executing right now. Long ago, computers never had that. The computers were fed data whilst they were actually running. That was how it used to be. So you would have something like a computer here, and every time it wants to carry out a computation or execute an instruction, you as the human being here have to come and give it data, and the computer would carry out the instructions and use that data to produce a reasonable output. So That became cumbersome. Like always, you have to be there as a human being to give the computer instructions and information to execute a program and to give you a reasonable output. So it became cumbersome, and von Neumann actually discovered, what about if a computer could actually store the instructions on its memory and execute those instructions? So that's what von Neumann actually thought of. He thought of, hey, I give a computer its instructions, it stores those instructions, then it executes those instructions by simply getting those instructions from memory. And with this, it revolutionized computer architecture as it made the computer even faster and more efficient. That's what von Neumann did. To add to these videos which I'll be posting about computer architecture and all those things, we're gonna learn different components of the CPU itself, the like maybe the CU, the PC, registers, and all other things. And by the end of these series of videos, I'll actually post a video in which we'll write code using machine code, and we'll use this computer simulator here to actually see how your computer is actually executing instructions. So this computer simulator was actually from choose.withcode. You can Google it up and you'll find it. We're gonna use this to actually write a simple program which will maybe add up numbers and all those things and see how the computer actually executes those instructions. So in the next series of videos, we're gonna learn about the PC. We're gonna learn about the memory address register, which is simply abbreviated as MAR, ACC, LLU, MDR, CIR, maybe CU, control bus, data bus, address bus, and the decode unit, which I don't even know how it works, but we're gonna learn about it. You also are gonna learn about the random access memory, which is the RAM. And finally, so from this you can actually see the von Neumann architecture. This is what von Neumann actually thought of. He thought of something, a CPU here, and the CPU is everything that has a background of pink sort of pink, and that's the CPU, and this is the RAM. So this is where your program is being stored, and the RAM stores the program. Then the CPU will get those instructions one by one, execute those instructions, and store them back to RAM. That's how the von Neumann architecture was thought of. So the RAM stores the program, the computer executes, then it stores the output on the RAM again. We will see this by simply tackling each component piece by piece until finally we reach to the level where this will actually make sense. So I'll see you in the next videos. Please leave a like, share, and subscribe, and continue supporting JFB. Thank you.